Page 438 in your textbooks. You did the review 1 through 23 odd. Some basic fraction review, really nothing to do with what we've been working on the last couple of days with complex fractions or rational equations, but a good overall review of some fractions as well as some other things we haven't looked at in a little while. So good refresher for us there. Page 438, 1 through 23, the odd other than 7, 19, and 21. Should we simplify those numerators? All right, let's go and take a look at these, see how we did. Number 1, really straightforward equation, like what you would have done in like 6th grade. What did you get for your answer, Maddie? 2. X equals 2. Number 3, not so straightforward. Got absolute value in there. That's not something you learned about till this year. And one of the interesting things about absolute value class is you're going to have how many answers typically?
2.
Usually 2. And what were the 2 answers on number 3, Gavin?
-1/2 and -9/2.
Good. -1/2 and -9/2. How many had those answers? -1/2, -9/2. All right, real quick refresher on the absolute value equation. You want to isolate the absolute value, and technically that was already done for you, wasn't it? Then we're going to set whatever's in the absolute value equal to both positive this and equal to negative that. So, because again, this quantity could either be a positive 4 or negative 4, because when you take the absolute value of 4 or negative 4, it would equal 4. Of course, we'll move the 5 over to -5 to get the 2x equals -1, hence the -1/2. Also send the 5 over to -5 here to get -9, hence the -9/2. Questions? What about on number 5? What did you get for your answers? Noah?
8 and -10.
Brecken?
2 and -8. But no solution.
No solution. Remember, absolute value can't equal a negative. So anytime you see absolute value equal to a negative, it's just no solution. All right, question on number 5. Good refresher for us, right? That's why we have these review assignments every so often, so we don't forget things like that. Skipping over number 7, number 9, 3 consecutive integers whose sum is 75. How would we represent 3 consecutive integers, Noah?
X plus 1, X plus 2.
And so when it says that the sum is 75, that would give us an equation of?
3x plus 2 equals 75.
And you end up getting x was equal to? 24. So what were your actual integers?
24, 25, 26.
Good, 24, 25, and 26. How many had those answers for number 9? Question? Did you have the setup correct?
I just forgot that I didn't do the equation.
You represented x plus 1, x plus 2, and just kind of left it? All right. You represented the integers. We wanted to actually solve for them. Number 11 wanted us to simplify. And that's a very generic way of talking in algebraic terms. Generally, when we're working with fractions, we don't use the term simplify, class. We would use the word reduce. Right? When it comes to fractions, we generally would say reduce. Well, in order to reduce fractions, that means we have to cancel some stuff, right? But Brecken, we remember you can only cancel. You never cancel. So as tempting as it would be to a novice to just cross out these x squares, I'm sure none of you just crossed out the x squares. Oh no, Brecken, you would have made sure you factored first, wouldn't you? And Brecken, in this denominator, I'm not sure why everyone's laughing. In the denominator, Brecken, you factored out an x. Yeah, that left you with what? X -3, right? And then you canceled away in the denominator with one of the to leave us with. So your answer was, but because this x canceled away from the denominator, you also said that that x could not equal 0. Great job on that, Brecken. How many had the same answer Brecken had on your homework? All right, questions on this? All right, number 13. Again, you can't just cancel stuff away. We've got to factor first. Maddie, what was your answer for number 13?
1 over x plus 4.
Good. We factored the denominator into x -3, x +4. Allow the x -3 factors to cancel. Good, not just saying x plus 4, but 1 over x positive 4. And then you also specified that x cannot equal 3. Great job. Number 15, it's really tempting to want to cancel the a minus b with the b minus a, but do they actually cancel, Noah? No. Because b minus a is not the same as a minus b. Noah, what should we do here in order to reduce?
Flip the a and b.
Where?
Put negative a in the front and plus b in the back.
Right here, so make this a negative 2 times negative a positive b like that. Okay.
And then factor out negative.
All right, now I've already got a negative out here, so if I factor out another negative, that's like negative 2 times
A
a negative b, but really a negative is just positive, right? So we end up with 5a negative b over a positive 2a negative b.
The a negative b cancels.
So your answer is
5 halves.
5 halves. The book would have you specify that a cannot equal positive b. However, again, what a, what b are we talking about? So I would contend we could leave it at 5 halves. How many had 5 halves for number 15? Questions on the second negative canceling with the first. The other option, of course, would have been to pull a negative out here, make it a negative a positive b, cancel that way, and now negative 5 over negative 2, those two negatives would cancel. Okay, questions on that? All right, number 17. There's a multiplication and there's a division, but we certainly wouldn't write the problem down the way it is in the textbook. For one thing, I'd rather factor as I copy it because I'm just lazy like that. I don't want to take all that time to write that big, huge, long problem out and then factor it and then, no, can't be doing that. So that first numerator, Gavin, I would write down
X times x negative 3y.
that first denominator, Noah.
X negative 3y times x negative 3y.
Then it says multiply, so I'm going to put my multiplication, another fraction bar, but I'm not going to write down 3x negative 9y, Brecken.
3 times x negative 3y.
Nor, Maddie, will I write down x squared negative 9y squared. And I'm certainly not going to write down a division symbol, Gavin. We're going to multiply by the reciprocal. So I'm going to make that a multiplication, and I'm going to look at what was in the denominator, the x squared positive 5xy positive 6y squared. I'm going to move that up and factor it, Gavin.
X negative 3y, x positive 2y.
Oh, Gavin. I think you forgot to flip it. Look in your textbook at number 17.
Yeah, I was looking at the wrong part.
Yeah.
X
So we're going to take the x squared
positive 2y.
positive 5xy positive 6y squared and move it up to get.
X positive 2y, x positive 2y.
There we go. And then I'm going to take what was in the numerator, the x squared negative 1xy negative 6y squared, move that down, Noah, to get.
X negative 3y, x positive 2y.
And that's how I'm going to copy it. Going to do most of the work in my head. Now comes the fun part. That was the hard part. Now for the fun part, Brecken, we get to, oh boy, what do we get to cancel?
X negative 3y. X positive 3y. X positive 2y.
All right, so what are we left with? Don't pull a Maddie here. Slash Mr. Tedeschi. I'll share your blame there, Maddie. Don't pull a Maddie slash Mr. Tedeschi here. 3x in the numerator. It's hard, isn't it? I mean, legitimately, it's so easy to miss those. I like it. Good. Not x negative 3y, x negative 3y. As far as writing it out for canceling purposes, sure. As far as writing it out for an answer, nah. A little squared on there, make it easier. Excluded values. Well, this x negative 3y obviously still has representation. X negative 3y, I just said it, still has representation. X positive 3y is not represented anymore, class, so we need to say that x cannot equal negative 3y. We would also need to specify x cannot equal
Negative 2.
There's our answer on 17. How many had this answer for number 17? Excellent. Good. Several of you. Questions on this? Questions on this? All right. And then let's see, we skip 19, 21, dropping down to 23. It's a subtraction problem. Now, a couple thoughts. First of all, do we ever really subtract, class? Now, we add the inverse. But we also know that in order to add fractions, you have to have a common denominator. And as we look at the denominator, I see polynomials. And what do I always do to polynomial denominators, Maddie? We factor them up. So I'm not even going to write the problem as written in the book, Maddie. I'm going to write the first fraction as. And I'm going to go ahead and just mark that subtraction there so I remember that it's there. And then, of course, we'll put the 3x over, Gavin. All right, so we put them in factor form. We remember not to lose that minus or that subtraction or that negative there, if you will. And in an addition problem, the first thing we need to do is figure out, class, what is the common denominator? What is the common denominator, Brecken? There we go. And so once I figure out what the LCD is, I want to draw, class, a big long line. And underneath the big long line, we're going to write down, Brecken, and as we look at the first fraction, what am I going to have to do to that first fraction, Noah? Right, multiply by the x negative 3 that seemingly magically changed. Nothing magical happens. I multiplied the x negative 3. And what I do to the bottom, I do to the top to get
6x squared plus 11x. 5x.
5 times negative 3.
Oh, 5x negative 15.
There you go, 5x negative 15. I'm not quite sure what you were looking at there. All right, for redemption, Noah, we look over here and we say, okay, what do I need to do to the second fraction?
Multiply by 2.
Multiply by 2. But remember the negative. So Noah, what do I write down?
Negative 6x.
Good, not 6x, but negative 6x. But I can't leave it like that, right? We have to do some simplification, Maddie. We need to do some combining. Good, negative x, negative 15, all over the 2, x plus 1, x negative 3. And, but I also still can't leave the answer like that. What's still not quite right, Gavin?
The negative up front.
Which one?
The 1 in front of the x.
Oh. Help him, class. The negative in front of the x only applies to the x.
Yeah.
I can only move a negative if it's the negative of the whole numerator. So what do I have to do? Gavin, back to you for redemption. Factor out the negative. And then I can move the factored out negative, which now represents the entire numerator. That can slide out front. So what should our answer be?
X positive 15 over 2 times x plus 1. X negative 3 by a negative in the front.
And that should have been our answer. For number 23, how many had that final answer on number 23? Maddie, great job. Just forget to factor out the negative.
I multiplied by the 2 and x negative 3 in the last.
Okay. Brecken?
Just brought the negative down and I left it negative 15.
Okay, so you did what Gavin tried to do a moment ago. So a reminder then to you, but other than that, perfect. All right, so just a little thing there at the end then. All right, questions at all on this? All right, we're not going to take time to practice a lot with it, but while I'm erasing the chalkboard, let's quickly review. What is a complex fraction? Noah?
It's a fraction with fractions.
A fraction with fractions in it. And the key to a complex fraction is to remember that it is simply, class, a division problem. It's really all it is, as long as the complex fraction has one fraction over one fraction. So if there were multiple fractions in the top, get a common denominator, combine them like we just did a moment ago to get one fraction over one fraction, or sometimes, no. It may work faster if we of the entire thing, of all the everythings, and multiply everything by the LCD, because by everything we mean the numerator and denominator. What you do to the top, you gotta do to the bottom. Why a moment ago couldn't I just multiply everything by the LCD? Because it wasn't an equation. But what we started looking at yesterday, those were equations, right? An equation has to have an equal sign. Good, bracket has to have an equal sign. If you have the equal sign, then what you do to one side, you can do to the other. In the case of the complex fraction, what you do to the top, you do to the bottom. In the last problem, there wasn't an equal sign, so you couldn't do to one side what you do to the other, because there weren't two sides of anything, right? There wasn't, I mean, yes, within each individual fraction, what you do to the top, you had to do to the bottom, but you couldn't just multiply by the LCD. You had to get the long line with the LCD below. But on page 441, as you turn, number 6, here we have an equation. So here, what we do to one side, we can do to the other. However, as you look at number 6, specifically on page 441, as you look at number 6, on page 441, you notice that's an extra special rational equation. It is one single fraction equal to one single fraction. I told you yesterday that something like that is called a Gavin's looking right at it. Gavin. Proportion. A single fraction equal to a single fraction we call a proportion. In class, how do we solve a proportion? Cross multiply. Now again, you could say, well, multiply everything by 10x. And frankly, it's going to work out the same way either way. But again, it's just a little bit quicker way of looking at it. So go ahead and copy down number 6 on your paper. X negative 3 over x equals 7/10. But we're going to solve it just a little bit quicker, because we're going to simply cross multiply. Meaning, take this cross product, notice not cross canceling. That would be in a multiplication problem where there's a raised dot right here. This has an equal sign. We're going to cross multiply, not cross cancel, to get what, class? And we're going to set the product of one cross multiplication equal to the product of the other. Again, from your junior high days, we would say that the product of the means equals the product of the extremes. So that 10x negative 30 has to equal, class, 7x. At this point, I'm going to pull a double switch. I'm going to send the 7x class over as a, to get, send it over as a negative to get 3x. And then let's also send the 30 over as a, to get 30, because there's nothing else over there, right? Nothing to combine with. And now we simply get x is equal to 10. Now, there was something x was not permitted to be. X could not be 0. X isn't 0. It's 10. We're good. If you wanted to check it, you could, and it's almost insulting how it comes out. 10 minus 3?
7.
Over 10. Is 7 over 10 the same as 7 over 10? Yeah, anyway, that's slightly. Anyway, questions on number 6. All right, let's drop down to number 10 now. And this is not a proportion here on number 10. We have 2/3 minus 5x is equal to 1/3. Not a proportion. I cannot cross multiply. Here I've got to multiply, class, everything by the LCD. What is the LCD here, Maddie? When I multiply by the 3x, of course, we're going to cancel some things away, Bracken. What's going to be left over here? There we go. And to solve, what should I do next, Noah? To get. And so therefore, class x is equal to 8. Pretty straightforward. Now, one word of caution though. Whenever you multiply by a variable, it's possible you could come up with an answer that doesn't work. Not that you did anything wrong, it just is an extra answer that's been created through the solving process that just doesn't work out. We call that answer, anyone, an extraneous root. You read, well, no, a class, say it with me. Extraneous root. One more time. Extraneous root. So class, what do we call an answer that might have been created that just doesn't check? Extraneous root. And one way of checking for extraneous roots, the easy way, is to see, are there any values that just straight up, it couldn't be this? Well, the only thing x couldn't be straight up, class, is 0, at least based on first glance. Let's go ahead and check the 8. We have 2/3 minus 5 over 8 is equal to 1 over 24. Well, the only way to know that would be to get the common denominator of 24. So you multiply top and bottom by 8, that gives you 16 24s. Multiply top and bottom by 3, that gives you minus 15 24s, is equal to 1 24th. Is that a true statement? Yep, it is. And so it does check out. X does equal 8. Not an extraneous root in this case. Questions on 10. Let's take a look at number 13. Copy this one down. 1x plus 1/4 equals 1/12. 1x plus 1/4 equals 1/12. Walk me through what we should do here, Gavin.
Get the common denominator.
Okay, which is?
12x.
What do I do with that common denominator of 12x?
Multiply everything by the other.
Good, multiply everything by the 12x. So when we multiply the 12x through, Gavin, what does it leave us with for our answer?
12 positive 3x equals x.
There we go, good, because the x's cancel, 12 and 4 to get 3, and the 12 and 12 cleanly. Then what?
Move the x over and move the 12 over together.
Good, double switch. Bring the x over and send the 12 over to get?
2x equals negative 12.
And therefore x is equal to?
Negative 6.
Perfect. We can check, but it does indeed check out. 1 at negative 6 plus 1/4 does equal 1/12. And the only thing x couldn't be right up front would have been a 0. Questions on number 13. How many, as Gavin was working through, you were right there with him saying you knew every step of the way. Excellent. Let's practice just a couple more together. Number 15. Go and copy it down. We've got a 3a positive 5 over 6 plus negative 10 over a. They're helping you a little bit here. Instead of saying minus 10 over a, they went and put the negative up there. Just leave it up there in the numerator. That's more of a help than a hindrance. Is equal to a halves. And Brecken, walk us through. Good. Again, a short little denominator like this, I'm going to write it each time. Remember yesterday, though, I said if you've got a really long denominator, you may want to very carefully skip that as part of writing it each time. All right, then what?
3 squared plus 5
Excellent distribution.
negative 60
Excellent.
equals 3a squared.
Good. Now, on the surface, it's like, oh no, as soon as I got that a squared bracket, I'm thinking, oh man, a quadratic. But is it really going to stay quadratic? No, because... So now what do I do? Well, yeah, technically it is already equal to 0. To get, and therefore, a simply equals 12. Very good. Think of the clock, right? Every 5 minutes is another number, and there's 12 of those 5s going around the 60 minutes. The only thing a couldn't be was a 0 all along. A equals 12, and it does indeed check out here on number 15. Number 17. One more here. Number 17, copy it down. And we had x minus 3x is equal to negative 2. And let's go to Maddie. Walk us through this one. this one, unlike Brecken's, Maddie, it's not gonna leave the quadratic form, is it? The quadratic-ishness doesn't cancel, and that's a new word I just made up. So it really is quadratic, so I'm going to have to set it to get then backwards FOIL, right? Factor comes next, right? Set it to 0, factor. What are our factors here? Excellent. Set each of the factors to 0. And what are our two possible answers, Maddie? I'm sorry, -3 and what?
1.
Oh, I'm sorry, I thought I heard positive and -3. I'm like, I know that can't be right. I heard the -3 for sure. +1 and -3 look like my answers. Now, right up front, class, we know there's one thing x could not possibly have equaled. Right, we knew x couldn't be a 0 to start with, right? Well, that wasn't one of our answers. But with a quadratic, it's very possible that one of these is extraneous. Let's start with the 1 first, because that's easiest. We plug in a 1, obviously that's 1. What is 3 over 1? 3. So 1 minus a 3 equals -2, true or false? True. So the 1 checks out. Let's try the -3. Obviously, in place of x, that's just a -3. But here we have a 3 over a -3. -1. So it's minus a -1 or plus a +1 equals -2. Is that true or false?
No.
True.
True. -3 plus a +1 is -2. Neither one happens to be extraneous, but especially on the ones that turn quadratic, you'll need to check. Can I have you work 5 of these on your own now? Numbers 2, 8, 11, 12, and 14. They're on page 441. Working quietly at your seats. Good, Maddie. Take another minute and a half or so to finish up. Take one of these together. Good. Noah and Maddie, I want you to work on. I want you to tackle 31. Tackle 31. We're going to look at it together in a minute, but I'm curious to see if you did before we even go over it. Go and put your pencils down. Even if you're not finished, let's take a look here. The first 3 problems that I assigned you, 2, 8, and 11 class, all of them are simply proportions. Thank you, Gavin, class. All 3 of these, because it's just one fraction equal to one fraction, class, we call proportions. And how do we solve proportions, class? Cross multiply. That was weak. Class, how do we solve proportions? Cross multiply. So Brecken, here, we'll multiply one cross product, and we'll set that equal to the other cross product. And very simply, class, we get an answer of x is equal to 21. Probably, if you think back to the way you solve these in junior high, you say, oh, times 3, 6 and 21, right? Probably planning to solve that in your head. How many got 21, though, for your answer? On the next one, then, Brecken, I'm going to stay with you. What would we get for our equation?
3
And then we needed to do what? There we go. And we're done. We can check 12 minus 8, 4 is 8 over 12, and 8 12ths does indeed equal 2/3. X couldn't have been a 0, but it obviously isn't. How many had 12 for the answer here? Looking at the next one, Noah, what do we get when we cross multiply?
2x equals 4 plus 12.
From there, you
Bring the 4 as a negative.
to get,
6x equals 4.
and therefore x is equal to
2.
2. And interestingly, if you plug in the 2, you get 5/4 equals 5/4. So x equals 2 is our correct answer. X could not have been a 0 here. How many into 2? Excellent. Not a proportion. So what do we have to do here? Gavin?
Multiply everything by c,
Which is?
2x.
And when I multiply everything by 2x, the equation becomes?
4 plus x equals 6x.
From there?
Move the x over to get a 5x.
Is equal to 4. So x is equal to?
4 over 5.
4/5. It's nasty to want to check. I really don't want to check. But here goes. All right, so 2 over 4/5 plus 1/2 equals 3. What did I just create by trying to plug in a 4/5 class? A complex fraction. And a complex fraction is simply a division problem, which we multiply by the reciprocal. So it's really 2 over 1 times 5/4, where I can cancel away the 2 and the 4 to get a 1 and 2. Really, class, this becomes 5/2. 5/2 plus 1/2 equals 6/2, which equals 3. I guess it wasn't that bad to check, but yeah, never been to think of complex fraction there. How many got the 4/5 for number 12? Question? All right. And then on this last one here, Maddie, we need to multiply everything by 3x, and when we do, the equation simplifies to? From here, you, to get negative 2x, don't lose the negative, is equal to 6. And when we divide, we're dividing not by 2, but by negative 2, so that x equals, and as long as you're careful with the negative, that's not a problem at all. How many got negative 3 for the answer? All right, let's check real quick. Of course, we already know x can't be 0. That's 3 over negative 3 minus 2/3 is equal to 5 over negative 3. Well, this really is a negative 3/3, right? We can slide the negative out front and say negative 3/3, negative 2/3. We can slide this out front, negative 5/3. Is that true? Negative 3/3 plus negative 2/3 equals negative 5/3? Yep. And it checks out. Negative 3 questions on number 14. Going once on questions. Twice on questions. All right. Coming down number 16. We'll do a few more of these together as we round out the hour. Number 16, if you would. Brecken, walk me through. Okay.
Multiply everything by 2 negative x equals 3x.
And what have we gotten all of a sudden, Brecken?
Quadratic.
A quadratic. In a quadratic equation, the key first step to solving the quadratic, class, you gotta set it equal to 0. Which side should I make the 0, the left or the right? The left this time. Normally the right side becomes 0. Here we want the left to become 0 because the 3x squared is positive. If I were to move it, it would become negative. Brecken, what do I get on the right-hand side then?
3x squared positive x negative 3.
All right. And from here we should?
Get 2 thingies, right?
Yeah, what do we call this when we get 2 thingies? Class? Yeah, they're binomials, yeah, but what do we call them when we get the 2 binomials? A word we've been using a whole lot of?
Rational.
A word that's been on the side of the wall for months now, it feels like? Factoring! Yeah, factoring. All right, so when we factor here, Brecken, let's start. Now, it's not as straightforward as x and x this time, is it? It's going to have to be 3x and 1x. Signs? And the only way to split up a 2.
2 and 1.
All right, 1 and 2 or 2 and 1. I like the decision to go 2 and 1 here. Checking your outer, inner. Switch the signs. So make it a positive 1 and a negative 2. And once we've got our factors, what should we do then? Good, set each one equal to 0 to get what for our possible answers?
2 over 3 and 1.
When you move that 1 over, it becomes a -1. And these appear to be my answers. Of course, initially we see x couldn't be a 0. Let's check the -1. What do you get when you square a -1, class? +1. 2 divided by +1, 2. And then we've got a -1 over -1. Well, those two negatives are gonna cancel to give me just true or false? True, of course. Let's try the 2/3 now. What do you get when you square a 2/3?
2/3 squared.
4/9. Square the top, square the bottom, right? So we get 2 over 4/9. Well, once again, we don't really work with the complex fraction. We're going to have to change this to say anyone.
2 over 1 times 1 2.
All right, anyone can jump in. Thank you, Brecken, there for giving that to me. Cancel to get class 1 and 2, so we get 9/2. Okay. Then we come over here and it says -1 over 2/3. So what do we have to do now? Again, multiply by the to get
1 over 1 times 3.
and that gives us
3/3.
minus or -3/2. And what is 9/2 minus 3/2? 6/2. What's 6/2 equal to?
3.
They both do check out. No extraneous roots. Once again, kind of lulling you into a false sense of security, right? Typical person, you're like, hey, we haven't had an extraneous root in a long time. We don't even have to check. This book is like the devil. Right? The devil devil's like, yeah, let's let you get away with sin for a long time. But it always comes back in the end to sting you. So we got to keep checking, right? Don't get too comfortable here. Let's take a look at 31. A couple of you started it, Maddie and Noah. Did either of you finish 31? Both of you did. All right, well, let's see how we did here. I'm not going to write down what we've got in the book, though. I'm going to write down as x minus 1 over, you two help us out, as the rest of you copying down with me now.
X -3, x -2.
Right, let's write it down as x -3, x -2 is equal to, and then it says x -2 over 2 negative x.
Negative times quantity x -3.
Right, I'm going to factor out the negative. I'm actually going to slide it all the way out here and make it an x -2. Now, everything in me wants to cancel right here. But I've already got an x -2 here, that if I were to cancel, I just have to put it back in. So I'm actually not going to cancel here the x -2's, though I could. And then it says minus 1 plus x over x -3. And again, grouping those denominators as I go. Maddie, did you also get the negative out? And slide it out front? Excellent. So, unlike past problems where we had to draw a long line, because of the equal sign, I'm going to multiply everything, class, by, which is in this case, right, the x -3, x -2. Well, I'm not going to write it every single time because I'm lazy. Hopefully you didn't write it every single time because you're lazy. You did write it every time. That's okay. All right. But here, what would cancel, class?
X -3, x -2.
All of it. So would I multiply anything? No, I would just keep.
X -1.
Right here, I would cancel the,
X -2.
but I would still have,
X -3.
and so that has to be multiplied. I also have to remember the negative. So let's FOIL, but as we write it down, class, pay attention. As I write it down, I've got to change the signs. So my first would be,
X squared.
but it becomes,
Negative x squared.
the outer inner would be
Negative 6. No, 5x.
negative 5x, but I write it down as,
Positive.
and my last would be
Negative 6x.
last, negative 2 times negative 3.
Positive.
Positive 6, but I'm going to write it down as a
Negative.
negative 6. Questions on what we just did there? All right, so when we come to our last fraction, what would cancel, class? The x -3. So what would I have to multiply still?
X -2.
The x -2. And once again, after I FOIL, I again have a negative. Now this one's kind of weird because instead of x plus 1, it's 1 plus x. Thoughts? Just make it x plus 1, right? The sign's positive anyway, right? Addition is commutative. That'll make your FOIL easier. That's the only reason I would do that. So our first class, x squared, but I put outer inner, negative 1x, but I put positive 1x, or positive x. Am I last? Negative 2, but I put
positive 2.
Questions on that process? All right. Now comes the sort of fun part. Combining. I've got a negative x squared. I got another negative x squared class.
Cancel.
Ooh. If they were on opposite sides, I would cancel. And I think the book may have been checking to see if you'd fall for that. They actually have to combine to get negative 2x squared. I've got a 5x and another x.
6x.
And I've got a negative 6 and a positive 2.
Negative 4.
All equal to x negative 1. Oh, that means I've got a quadratic, which means I need to set it equal to
0.
Noah, which side should be the 0?
The left side. Or the right.
The right. Why the right, Noah?
Because of, I have no idea.
Well, the x squared right now is, do I want it to be negative?
No.
How do I make it positive?
Switch it.
Move it over, right? And that becomes then 2x squared. That means we also have to bring the 6x over as a,
Negative
to get
negative 6. Or negative 5.
and I also have to bring the negative 4 over here as a,
Positive 4.
to get,
Positive 4.
all right, making edits to your work perhaps? All right, Maddie looks like she's making some edits as well. That's okay. Did you figure out though where you went wrong, Maddie? Was it perhaps with changing of signs? Okay, so again, a little word of caution there. That's why we're doing this one together. Let's go ahead and factor. That's an important word to keep in mind. The 2x squared class,
They're 2x.
positive sign, of course.
Both negative.
And the only way to split up a 3,
1 and 3.
1 and 3 or 3 and 1. Which one? 1 and 3 or 3 and 1?
1 and 3.
Outer, inner, yes. So, set them both to 0. What are my 2 possible answers for x?
1 and 3 and 2.
1 and 3 halves. Now, are either of those values excluded per the original? No, the only things it couldn't be was a 2 or a 3 before. I didn't get either of those answers. And there they are. Ooh, something that ugly. I really don't want to check, just to be quite honest with you. I think I'll pass. It had 2 chances to exclude one. I didn't exclude any. I'm sorry to leave it. All right, well, we are out of time. That's some extra credit for you this evening if you want it. Extra credit this evening if you'd like it. Page 441. Page 441. Numbers 27 and 34. Page 441, numbers 27 and 34. You do need to make sure you have graph paper with you Monday. Graph paper on Monday. That's in lesson 111. So 3 more lessons from now. Lesson 111 on Monday. Make sure you have graph paper with you. All right, you are dismissed. Have a wonderful rest of your day.